K8BYP with part 2 of a video I did a while back on the fallacy of using twin lead. The false belief that twin lead should be used because it's more efficient. I cited an absolute authority, not ARL's nonsense, not ham radio myth, that while twin lead with an air dielectric might be very low loss between the conductors, there are tremendous losses otherwise. And that is ignored in the pursuit of relying on an oversimplified fallacy. Well, lo and behold, I'm not the first person to notice this. QST magazine, when there was a real ARL instead of a button-pushing ARL, and when QST was full of highly technical stuff and interesting to read. Most of it was stuff we couldn't afford, but that's a different question. But from worldradiohistory.com, QST 1964-02 PDF, February 64, VHF Antenna Facts and Fallacies, Part 2, Choosing the Right Transmission Line by Edward P. Tilton, W1HDQ. The best antenna in the world is of little value if it cannot be made to take power from the transmitter and transfer the signals it intercepts to the receiver. That's what happens with the wrong transmission line. That's what happens with twin lead. That's what happens with the fallacy of using a high characteristic twin lead such as 300 ohms to try to load a 50 ohm dipole. It's a joke. Coax, twin lead or open wire. Coax has relatively high losses in the tables. He's talking about UHF here. VHF, UHF, 2.5 dB per 100 foot at 144 megacycles. Well, duh, don't put the transmitter 100 foot away. Would that fix the problem? That means 100 watts at the transmitter will be about 57 at the antenna. Probably, because solid dielectrics have more losses. Right side column, twin lead is inexpensive, convenient to use. Its advertised losses look good on paper, which is admitting that advertised losses are BS. The best grade tubular twin lead transmitting type, 1.25 dB per 100 foot. That ain't a big difference. What's 1 dB? 2.3 dB at 420. Anyone who has used it knows that polyethylene insulated balance line is a terror in rain. Flat ribbon types give the most trouble, but even the best tubular line will give you a bad time with fluctuating and loading and heavy rain conditions. Cheap lines, small conductors, thin insulation should be avoided like the plague, unless the line is only a few feet long and used indoors. Book figures make open wire line look best of all, because the book is lying. If a good open line only has 0.2 dB loss per 100 foot at 144, why didn't everybody use it? This picture has the biggest ifs. Such fine performance is achieved, if ever, only with large conductors, spaced so that radiation is nil, and that alludes to what the PhD author I quoted talked about twin lead coupling to everything around it, and held in precise alignment with a minimum of insulating spreaders. No sharp bends. Conductors must be balanced to ground. There it is. Balanced to ground means run horizontally, not vertically. We do not make pieces of SHIT called G5RVs with twin lead going vertically. Balanced to ground means balance between both conductors along the entire length, and that means horizontal. These conditions are definitely not met in most amateur installations. The author was sadly disillusioned with the 220 megahertz open wire line job some years ago with a 125-foot run installed with a fair amount of care and using half-inch space line, which is wide. We found that 70 watts output at the transmitter showed up as less than 25 watts at the antenna, and the ground sucked the rest of it up. Now on to the lies, myths, and the bullshit about balance. This was the best line available, ready-made at moderate price. Where did the 4 dB loss come from? First, there were 2 coaxial balance. And balance are supposed to be used in transmission lines, but they're lossy as all get out. And hams are blind to this. Our transmitters have coaxial output, and rightly so. To get from this to a balanced transmission line requires an antenna coupler or a balun, bound to be some loss increasing with frequency. Another balun was used at the other end so that the coax could be used for trouble-free rotating section, but most of the trouble probably came from radiation at bends in the line and from unbalanced introduced at insulating supports attached to the tower. Well, the open line's also coupling to the tower, so now you've got a different transmission line configuration. Now they went to considerable amount of trouble making an open line pay off, and with all the ridiculous trouble they went to, the losses were about the same as so-called coax. 2.3 dB at 432, so they went up a band. That's still severe losses. Put the transmitter closer to the blinking antenna. Isn't this obvious? And still, even this author who's getting most of it right is still blindly ignorant to the fact that there are horrifying losses between a line and ground. Ground is a horribly lossy dielectric even at HF. Open line allows coupling to anything else out there in space. Losses, fields going in some direction that's not good. Whereas concentric line is self-shielding and almost usually keeps most of the field inside of it, so it's not lost. The plus there is while the loss might be the same, you don't have fields spewing off an open line that are impinging on fields from the antenna that cause changes in antenna pattern. There's another downside of twin lead that isn't obvious if we don't understand electromagnetics. But this article both acknowledges what a balun's for and then contradicts itself, because baluns are not used from transmission lines to antennas. They're used to go from one transmission line configuration to the other to cause a coupling, realizing that with a concentric line, the fields are internal. With an open line, the fields are external, and the term field configuration was used by one of the authors I quoted in the first video. But the balun takes energy from one type of line, converts it to a circuit equivalent with all the losses, converts it back to voltages and currents, then couples it to the next line, which then converts it to its own fields. That's what a balun's for, not for antennas. What was just becoming a thing then is foam dielectric, the expanded EPS, expanded polystyrene, considerably less loss. The modern LMR 475 I use is somewhere around 0.3 dB and 100 foot at HF. It's so low they don't even rate it, at times microwave. If it's that important, get a gas-filled hard line. Is it that important? Really? We can't figure out to put the antenna closer and maybe put up some plate shielding. Put it right outside the ham shack and put up some shield plates. But, hams are all about grounding things. Why don't they ground things in that case? The other thing I haven't harped on much is coax fittings. UHF fittings are not for UHF operation. End fittings, for anything about 6 meters and up, they ought to be end connectors. Article then goes on to refer to something called G-line, which is sold under fantastic claims of less than a dB and 100 foot. A single line. Yeah, it's a transmission line against ground, but the author is apparently completely ignorant of that fact. So hams waste a lot of time ranting about ground, but don't understand anything about electromagnetics and why that ground is an absolute disaster at HF, because it takes RF and gobbles it up for lunch, turns it into heat. There's no magic. If you want a transmission line that works, it's got to be concentric, not this stupidity of open lead, which contradicts the first principle in this article, which is correct. The transmission line's got to be matched to the antenna, and you will not match a 300 ohm twin lead line to a 30 to 100 foot 100 ohm dipole. You ain't going to do it. And when you try and get on the air, you'll find that I stomp all over your signal with 1 watt. So just plain simple facts, but you see, again, I'm not the first person to ever harp on this topic. And back in the day when ARL and QST were legitimate, they had articles like this explaining things in detail. Now it's just the Baofeng button-pushing crowd, which is just simply an insult to amateur radio. KBYP.